Finish this last chapter of the year, last section. Yep. Okay, I'm going to switch papers. All right, so here we go. We're going to look at some special solutions of linear systems. So far, you've pretty much been working with this right here, right? Two lines, they intersect, that is the solution, the ordered pair. And actually the answer here, there's 1 point, you should write this down, 1 point of intersection. And for this one, it happens to be 2, -1. That is when you have one solution, when you get an ordered pair. You actually get an ordered pair. One solution. Oh, wait a minute. What do we have here? We have two what? Oh, so they're parallel. Now, you can tell by the picture, but you can also tell by what? The slopes are the same. Same slopes. They will never intersect. Never intersect, so there's no solution. No solution. Because the solution is where the lines intersect, correct? And if they're parallel, they're never going to intersect. Okay, so here, this one's kind of weird. This is infinitely many. Now, you have two equations here, right? So I graphed this one, starts at 1, went down 2 over 1, kind of looks like that. It's not an exact graph. If I solve this for y, let's do it right here, real small. I'm going to get y by itself. So I'm going to subtract 4x. You see that, correct? Okay, I'm going to write that down. 2y equals -4x plus 2. So ultimately I'm getting y by itself here. If I divide everything by 2, watch what happens. Would you look at that? Look at this. That was my original. And look at that. They are the same line. So they intersect infinitely many times. They lay on top, one line on top of the other. It's the same line. So there's infinite points of intersection all along this line. Every single thing that makes up that line is a point. So there's infinitely many points of intersection. Infinitely many solutions. Do you get that? Okay, so these are the 3 situations you're going to encounter. Now, I put these here because this is what it's going to look like when you don't have a graph and you solve a system. You might get an ordered pair. If you get an ordered pair, that's one solution. Wait a minute. You might solve and you might get something like this, 0 equals 4. Is that a true statement? No, it's not true. And so if that happens, that means that there's no solution. If there's no solution, they have to be what kind of lines?
No solution.
Parallel. They're never going to intersect. Parallel. This is not true, so there's no solution. They have to be parallel lines. When you get something like that, which you will, we're going to practice this. Yeah.
I don't understand how they got 0 equals, does not equal 3.
This is not really necessarily related to this. What I'm saying here is in these instances, if you get an ordered pair, there's one solution. If you get something like this when you solve a system, an untrue statement, that tells you there's no solution. That's what I'm trying to show you here. If you get something like this, is 3 equal to 3? Yeah, that's always true, right? You could get 4 equals 4, 0 equals 0, 1 equals 1. If you ever get that situation, it's always true.
Let's just fast forward to December 24th.
Then there's infinitely many solutions because they're the same line. So these are instances that you're going to see when you're solving. That's why I put it in the same columns. Make sense? We'll practice. You'll see what I mean. Okay, turn it over. Let's practice what this will look like. So solve the system by graphing. Something you're going to have to do on the test. Put the phone away or it's mine. I say it every day to you, Clark, and I'm tired of it. Thank you. So, first of all, these are in standard form. Let's put a 1 here and a 2 here, my first equation and my second equation. If it's in standard form, what's the most efficient way to, yeah, easiest way is to make a baby table. So I'm going to put 1, I'm going to make a little baby table. Okay? So I'm going to put 0 for y and 0 for x, and I'm just going to come up with these 2 points. If I plug in 0 for y, that goes away, and then I divide both sides by 2. What is x when y is 0? 3. So I put 3 here. There's one of my points. All right, if I go back still to the first equation, and I make x 0, divide both sides by -3, what's my y?
35th hour.
I think I either have 30 or 33. I don't remember. Okay. Thank you. Okay, so y is going to be -2 when x is 0 in my first equation. So let's graph those 2 points. Over 3, up 0. Over 0, down 2. Connect them with as straight a line as you can. So that's my first one. That's line 1. Let's do line 2 now. Baby table. 0 for y, 0 for x. This way. Okay, so let's plug in 0 for y. When I do that, I have to divide by 2. What is x? -2. Plug in 0 for x. I got to divide by -3. I'm going to get a fraction. -4 over -3 is just positive 4/3. Hey, tell me in cookies. If you have 4/3 of a cookie, how much of a cookie do you really have? 1 1/3, right? 1 1/3. And you can graph that if you think about it. So -2, 0 is here. Then I have to go 0, 4/3. So I don't go anywhere, but I go up 1 and 1/3.
Why wouldn't the x for number 1 be 2? Because it would be 2 over 1.
If you plug in 0 for y, divide both sides by 2, you get x equals 3. This is saying to plug in 0 for y, correct? If I plug in 0 for y, that term is going to go away.
Oh.
Okay? So connect them as straight as you can. Oh, what do they look like? They appear to be what?
Parallel.
They appear to be parallel, so there is no solution. Parallel lines. So that's what you say. You can't come up with an answer. You just say no solution. You solved it. Okay. Notice I'm using green and red because I'm feeling festive. All right. Solve by substituting. So look, they have y equals this stuff. So I'm going to put it in for y. Into there. Okay? So I'm going to go ahead and substitute. So I'm going to write the first part of the equation is 4x minus 2. Then I'm going to plug in this stuff.
0. Oh, yeah.
Equals 8. Substitution. Okay? If it helps you, change that to adding a negative, which tells me that I have to distribute a -2. So I have 4x plus -4x plus 8 equals 8. What happens? When I combine these two, they cancel each other out, and I get 8 equals 8. Oh, is that a true statement? Yeah, so that's why I showed you these on the front here. When you get a true statement, that tells you what? Infinitely many solutions. It's the same line, basically, is what it's saying. Infinitely many. If you were to graph that, they would be one line right on top of the other. Yeah.
So if you were to like subtract the 8 first from the other side, that would get you 0 on that side, and then There's no such thing as 0x, so just be 0 equals 0, so it'll be the same thing, basically.
If you get a true statement, whatever method you do, if you get 0 equals 0, that's a true statement,
Can we
right?
just
Yes.
write true?
Okay? No. True doesn't tell me that you know the solutions. Does that make sense? You have to tell me infinitely many.
Can we just write infinite?
Yes.
Okay, because that'd be like, okay.
All right, so here's what you get to practice. Let's do these 4 real quick. They shouldn't take too long. Okay, this way. Tell whether the linear system has no solution, one solution, or infinitely many. So let's look at this. Does it tell you how to do it? No. And you all prefer elimination, I'm guessing, right? It's easier. So can we eliminate a variable as these are?
Yes.
Yes, we can. So we don't have to do any work. We can eliminate the x's.
3.
What? Oh.
We can eliminate both.
Add. Wait a minute. If they're both gone, do I just not put anything here? I have to put a what?
0.
I have to put a 0.
No solution.
This is 0. This side is a value of 0.
0
Equals
Oh.
9. What?
No solution.
That is not true. Which means there's no solution. Those lines are parallel. Okay? So really all you have to write is no solution. If you want to abbreviate, that's fine. Okay? All right, this one you may want to move it around and eliminate, but I'm going to substitute because that's the form that it's set up in right now. So I'm going to put that in there. So negative 6x plus 3. And then I'm going to put 2x minus 4 equals negative 12. I substituted. Then I distribute. Negative 6x plus 6x minus 12 equals negative 12.
Negative 12 equals negative 12.
Look at this. These two, when you combine them, cancel each other out. And you get this statement right here.
Infinite.
Infinite, yeah.
That's a true statement, which means there's infinitely many.
Infinity.
Okay? All right, let's do another one. It's already set up to eliminate, so let's eliminate. What could we multiply through by to eliminate?
Oh, 3. Wait, no. 2.
Yeah, but what kind of... Oh, we can multiply by through 2. Yeah, let's just do the top by 2 and we'll get rid of the x's. Okay? So I'm going to rewrite it here. I'm going to bring it down here and rewrite it. This is negative 6x plus 10y equals 12. So these cancel out. Oh, wait a minute. These cancel out. I have to hold this side with a what?
Y equals 0.
A 0 equals, those cancel out either. Oh, 0 equals 0. Is that a true statement? Yes, it is. So infinitely many. Zero equals 0.
Oh,
All right, let's do one more then. These are lined up. Can I eliminate right now?
Yeah, no.
I got to do what? Which one, top or bottom?
Bottom one.
Okay, let's multiply through by negative 1.
Yeah.
Because then I can eliminate the y's. So I'm just going to rewrite it over here. 9x minus 5y equals 12, and this is negative 5x plus 5y equals negative 8. These cancel out. I have 4x equals 4. Oh, I can see I'm going to get an x coordinate. So I'm going to need to set up an ordered pair, which already tells me what?
One.
There's one solution. They intersect somewhere.
Would it work if you did on the top times 5, and then on the bottom times negative 9?
Sure. It's just bigger numbers. So I'm just going to plug in 1 just to see what y is. This is 5 minus 5y equals 8. I think I'm going to get a fraction.
Yeah.
That's okay.
Why'd you do the bottom though?
It doesn't make a difference. You can choose whatever you want. You get the same answer if you did the math right.
If.
Negative 3/5. So I have one solution, obviously. You don't even have to write that. That's just your answer.
Can you just keep it in fresh?
Hey, Mr.